Welcome to SSI Meetup. Today we will be talking about DID Auth, and we have the privilege to have Markus Sabadello with us today here, who has been working on this subject for a long time, and he will be giving us a detailed explanation of how this works. Markus is the CEO of Danube Tech, and he's a member of the technical governance board of the Sovereign Foundation, and he's also involved in a number of different bodies that govern the internet, like the W3C and OASIS. And he will be telling us what the standards are of DID Auth today, how it's going, how it's working, and what the next challenges are. And if we check out the next slide number 2, let me tell you briefly about what we're doing at SSI Meetup. Basically, what we're trying to do is to empower global SSI communities to have knowledge, to have knowledge tools, to have access to key people in the SSI industry or the digital identity industry, and to make this as open as possible so that everyone can participate. So people from companies, from communities, or anyone who has any interesting to say in regards to SSI is really welcome to SSI Meetup. So please ping me if you're interested in participating in the future. And all this content is shared with the CC by Share Alike license, which basically means it's open source and you can reuse it freely. That's why we put this up in Google Slides, so you can download it in whatever format you need. And the only thing you need to do, as for today, if you reuse these slides for Markus, please mention Markus and Danube Tech as a source, and SSI Meetup as the place where you found it. And then you can just use them, and please reuse this content to do your local meetups or any other thing you want to do with it to grow the SSI community. So having said all this, if you have any questions at any point of time, as always, please just use the questions tool, and I'll bring those questions up to Markus to give his answers. And Markus, the floor is for you, and we look very much forward to learn about DID Auth today with you.
Okay, thank you, Alex, for the opportunity to do this webinar, and welcome everyone. I thought this webinar is going to be a little bit technical later, so before we get to the technical part, I'll just start with a lightweight and fun story to begin with. What you see here, this little animal, this is the main character from an Austrian children's book, which was first published in the 1970s. So it's pretty old, and if you've been to one of the major identity conferences this year, you may have seen this. But basically, it's a very, very successful children's book. It has been translated to multiple languages. Millions of children grew up with this story. Basically, this cute little animal, it has an identity problem. It doesn't know its own name, and even worse, it also doesn't know what kind of animal it is, right? So if you look at it, it's really hard to tell. So one day the little animal lives in a beautiful garden. It walks around and is generally happy with its life. But one day it meets the frog, and who lives in the same garden. And the frog asks the little animal, "Who are you?" And at that moment, the little creature realizes that it doesn't know the answer to that question. It doesn't know who it is. It doesn't know its name, and it doesn't know what kind of animal it is. So the little creature decides to leave the garden to leave its home and to go out into the world and explore. And it tries to find other animals, hoping that maybe someone else could tell it what it is, what kind of animal it is. So it meets the horses, it talks to the horses, it dives into the sea, it talks to the fish, it meets the dogs and all sorts of other animals, and it always asks, "Can you tell me who I am? Look at me, who am I?" But none of the other animals have an answer. The fish, the dogs, the horses, no one can tell the cute little animal what kind of animal it is. Nobody knows the answer. So after doing that for a while, the little creature gets really sad, and it gets really desperate, and it begins to doubt itself, to doubt its existence, and it asks, "Is it possible that I am no one? Is it possible that that I don't even exist at all. But then at some point, the little creature has a magical moment, and it's walking in the street in a city, and then it suddenly stops, and then it says to itself, it says, "Of course I exist. I am me," and that's the end of the story, and that's also the title of the book. So if you want, go and look it up. It's called The Little I Am Me. So the little creature is called I Am Me. And for little children, maybe at the age of 3 or 4, this is the valuable lesson here is that the children have their own personality. They have their own independent existence. Who you are is not something that others decide for you. It's not who you. It's not what your parents tell you. It's not what the other children at the kindergarten tell you. But you are a person with you can decide on your own who you are. That's the lesson from this children book for little children. For us, those of us who are working on DIDs and DID Auth and related technologies, I picked this story because I think this statement "I am me" is really at the heart of what we're trying to do, and I would argue that all of the identity technologies that we've been working on for many years, there's never been a technology that has allowed us to express this statement or to assert or to prove that I am me. We've always had protocols like OpenID or SAML or other things which is really about some provider or some entity or some company saying something about who we are, and then we can use that information somewhere. But we've never really built anything that allows us to say simply I am me. So this independent existence. Also, if you look at W3C communities, right, where people are working on verifiable credentials. Verifiable credential is an identity statement by someone about me. So here the assumption is kind of my identity is the set of things that issuers say about me. If you look at rebooting the Web of Trust communities, which is a series of events, there's a concept called functional identity, where you say that identity is how I keep track of others and how others keep track of me. Or if you look at identity concepts, let's say in Sovereign, where connections are an important concept, right? You establish connections with other peers. So there are all these models where identity depends on someone else or on relationships that we have with others, and how what others say about me and what I say about others. But there's always the core concept that I am me before we even go into credentials and higher level protocols, and that's really the main idea behind DID Auth. So before we even get into agents and credentials and relationships, simply the ability to say that I am me, and technically the core idea is to prove control of a DID. That's what we really mean by DID Auth. I think it's probably not necessary to go into detail about DIDs themselves. I think DIDs have been covered in the SSI meetup before. So these self-sovereign identifiers, right, that I can generate, that I can create using distributed ledger technology or using other decentralized networks. Now, for the first time, we have the ability to generate identifiers without central authorities, without intermediaries. And now maybe the most trivial or the most immediate thing that you can possibly do with a DID is simply proving that you control a certain DID, and that's what we mean by DID Auth. At this point, DID Auth is not a standard. It's not even a specification. At this point, it's a concept. It's this basic concept of proving that we control a certain DID. There's now a paper. It's called Introduction to DID Auth, which we started to work on at the last Rebooting the Web of Trust event this spring. And right now it's really a collection of thoughts or a collection of architectures and scenarios how exactly that could work. There are different variations of the basic idea of proving control of a DID. This can come in different flavors and in different concrete implementations, and we'll go into that a little bit in the following slides. On the technical level, one core piece in DID Auth and really one core component in any kind of interaction with DIDs is the DID document, right? So the core function that DIDs provide is you can, given a DID, you can resolve a DID to a DID document. That's what's going to be standardized across all the different DID methods. So no matter if you're dealing with a sovereign DID or a UPort DID or a BTCR DID, the DID can always be resolved to this DID document, and the DID document contains metadata that is necessary for trusted or trustable interaction with the entity that is identified by the DID. So roughly speaking, it means three things, or three interesting things that we can find in the DID document. So we can find public keys, cryptographic material, public keys associated with the entity that's identified by the DID. We can find authentication suites or authentication instructions, basically telling us how can we authenticate this DID, which is connected to public keys, so to the public keys. So as we will see later, DID Auth heavily relies on signatures and public key cryptography. And another interesting piece of information that we find in the DID document is service endpoints. The service endpoint is a way of communicating with the entity that's identified by the DID. So it's a way of transmitting messages, and we will see that this is also relevant for DID Auth. As I said, DID Auth can come in different forms and different variations, and it can have different architectures. But on a high level, this is sort of what you always have when you're trying to authenticate a DID. This is what all the different ideas and different flows have in common. There is an identity owner who controls the DID, who is identified by the DID. And then there's a relying party where we're trying to prove control of a DID. This could, for example, mean logging into a website with a DID. So in that case, the website would be the relying party, and I'm the identity owner. And typically, like many other authentication protocols and authentication concepts, in DID Auth, we think we rely on a challenge response cycle. So when we try to authenticate to a relying party, such as a website, for example, then the relying party will send us a challenge, a kind of cryptographic challenge, and then we will construct a response and return the response to the relying party. And we will construct this response based on, for example, the private key that we control. The private key has a corresponding public key which the relying party can discover from the DID document, and therefore the relying party can validate that the response was indeed constructed by the identity owner who controls the DID. And,
just Markus,
yes.
Sorry to interrupt. There's just one question here from Nick. He's asking, is relying party equal to verifier? Can you talk to sovereign versus other industry terms as you go along? I mean, that's just a suggestion, I guess. And we also have a question from Naveen. He's asking, in order to access the DID document, what do I need? Either DID or public key? So these are the questions that just came up at the same time.
Okay, I'll start with the second question. Given the DID, how do you get the DID document? That's a process called DID resolution, and we could do a separate webinar on that, I think, because that's also a really interesting topic. But so you need the DID, and given the DID, you can find the DID document. How exactly that works, that depends on the individual DID method. So that's very different for sovereign and UPort and BTCR and other kinds of DIDs. That's always quite different, but that's what DIDs provide. That's what DIDs specify and standardize. That's the functionality, that why they were designed, because they all provide this function that giving a DID, you can find the DID document, and therefore in the DID document you can find the public keys and the service endpoints and other information. And the DID document can change, right? So a DID is a persistent identifier. It always stays the same, right? Gives me the flexibility to change my keys, to rotate my keys, to change other information, but to maintain the same DID. And first question about the industry terms, we had a lot of discussions about these terms in the verifiable credentials community. The corresponding terms would be holder instead of identity owner, and as you mentioned correctly, verifier instead of relying party. We decided for now, and this is up to discussion, but for now we're keeping the term identity owner because it's just very effective politically, right? It really points out how this is different from other kind of authentication protocols. Historically, people have used the term identity provider, and we like to say that in DID Auth there really is no identity provider, because you are your own identity provider. You are the identity owner, and we're just using the term relying party instead of verifier, but it's essentially the same concept. What you will notice in this architecture, in this diagram, is that there are only two parties, right? There's the identity owner and the relying party, whereas in traditional identity authentication protocols like OAuth or SAML, you will always see three parties. You will always see the identity provider and the user and the relying party. But here we only have two parties. We have the identity owner and the relying party, because there is no intermediary, there is no central identity provider. That's the same. The identity provider is the same as the individual who controls the data. Moving on, so this basic approach of having an identity owner, having a relying party, and then proving control of a DID using a challenge and response cycle, as I mentioned, this can come in many different forms. So the way the identity owner and the relying party interact, this can happen through a web browser. It can happen with a mobile app. It could involve Bluetooth or HTTP posts or QR codes or JavaScript APIs. So there are lots of different variations that people are already working on today. Or we're calling that a transport, so that the challenge from the relying party going to the identity owner and the response going from the identity owner to the relying party, that can come in different forms, and we will look at a few examples what exactly that can look like. And there are also some variations depending on architecture and depending on the exact flavor of DID Auth. There are some variations as far as the details of the challenge and the response are concerned. So, for example, at the time when the relying party sends a challenge to the identity owner asking to authenticate, the relying party may or may not already know the DID of the identity owner. So it may say whoever you are, please authenticate now. That could be the case with a website, right? There's a website, and the website wants me to authenticate, but the website doesn't yet know what's my DID. But there are also scenarios where the relying party already knows my DID, and it just wants you to prove that you're really the one who controls the DID. In a similar way, in that cycle, in this kind of interaction, the relying party may also prove who they are. So there are some scenarios where this is sort of a one-way flow, a one-way interaction, where the identity owner just proves who they are. But it's also possible in some scenarios to do mutual authentication, where both the relying party and the identity owner prove to each other control of a certain DID. And so this is sort of high-level introduction to this challenge response pattern that we see between relying party and an identity owner to authenticate. I would now go over a few examples. So what can that actually look like in practice? What could be the concrete application or the concrete flow where an authentication step happens? So here's one example. Here's one example where the relying party is a web page. So there's a web page, and the identity owner through their web browser is looking at the web page, and the web page displays a QR code. And that QR code has an embedded DID Auth challenge. So imagine you're sitting at your laptop, you're browsing somewhere, and on a web page you see a QR code, and the web page tells you to scan that QR code with a mobile app, and that mobile app, that is where you control your DID. So that mobile app, using, for example, the sovereign technology, terminology, the mobile app that you have on your phone is an agent. It's an edge agent. It contains a wallet. I know agents and wallets have been covered already in the SSI meetup webinars. So you have a mobile app where you have your wallet that controls your DID. So with your mobile app, you can scan the QR code on the website, which you're viewing in your browser on your laptop. The mobile app can construct a response, cryptographic response to the challenge, and then post it back to the relying party's web server, and the relying party's web page, which you are viewing in your laptop, could be polling their own backend. So there could be a sort of a JavaScript polling or that's going on between the web page that you're viewing in the browser and the relying party's backend web server. And when the web server receives the cryptographic response from your mobile app, then you'll be logged in. You'll be logged into the web page. In order to validate the response, of course, the relying party performs this DID resolution step, right? So the relying party receives a response, cryptographic response. The response says, here's a DID, and here's proof that the identity owner controls that DID in the form of a cryptographic signature. So the relying party will resolve the DID, will look up the public key from the DID document, validate the response, and then consider the identity owner to be authenticated and to be logged in to this web page. So this flow, for example, is what Uport is doing, what Yolocom is doing, and a few others. It's logging into a web page by scanning a QR code that's displayed on the web page. Here's another flow which is a little bit similar. So again, there's a web page, and you're browsing the web page with a browser on your laptop. But in this case, the web page doesn't display a QR code. But in this case, the browser that you're using exposes a JavaScript API which supports DID Auth. So that's possible. For example, in the W3C community, there's something called the browser credential handler API. So that is an effort to actually specify a browser JavaScript API for authentication for DID Auth. So a web page would invoke a certain JavaScript API in the web browser. Then the web browser, which you're using on your laptop, could communicate with your mobile app again, similar as before. This is optional, I guess. So you could also have your agent and your DID wallet directly in your web browser. That's possible too. You could have a browser plugin where you have a wallet and control your DIDs, or the web browser could be connected to another device like a mobile app. But one way or the other, again, the cryptographic challenge is received. It's signed by your private key, and then in this case it's returned to the relying party by, again, through JavaScript by returning the response through JavaScript to the web page, and the web page could post it back to the relying party's web server, to its backend to log you in. So I think you can already see that there are a lot of variations, and these are not these are just examples of what DID Auth could look like. There's no all-inclusive list at this point of different scenarios, but there are just different approaches how it can be done. But there's always the identity owner who controls the DIDs, and there's always some challenge and response cycle. Here's an even more complicated one. I'm not sure if people are following, but here's please ask questions if it's not clear. But here's yet another one. Here's another flow where, again, you're browsing a web page. You're on your laptop with a web browser. You're on a web page, and you're clicking on a button on that web page. And when you click on the button, then in this case, the web server would now resolve your DID to a DID document. So at this point, the web server already knows what your DID is. The web server will resolve the DID and find an associated DID Auth service. So inside the DID document, there is this service endpoint where the relying party can send the challenge. The relying party will send the challenge to a DID Auth service endpoint, which is discoverable from the DID document, and then this is where the challenge is signed, and again, maybe maybe this has interaction again with the mobile app. So the DID Auth service, which by the way is a similar concept as in Sovereign, this would be called the cloud agent, and in a decentralized identity foundation, this would be called a hub. So it's a concept of a service that's running somewhere, that's hosted somewhere, but that's acting on your behalf, and it's this service that now receives DID Auth challenge, and through some interaction, a pop-up could show in your mobile app. The mobile app could say, do you want to authenticate? And then the response is posted back from this DID Auth service to the relying party's web server. So this is yet another variation. In this case, the advantage is that these two things are decoupled, right? So you have one channel where you're browsing or where you're doing some kind of transaction or interaction. And then the authentication channel where the challenge is sent and then the response is returned is sort of separate. And this challenge that's received by your DID Auth service, that's discoverable from the DID document, and it's independent. It's independent from the actual business or the actual web surfing or web browsing that you're doing right now. So these are some examples of what the challenge and response cycle and the login and the authentication process could look like, and all of this is described in some more detail also in the DID Auth paper that's available in the Rebooting the Web of Trust website. And in these examples that we've seen now, there's an identity owner, a user who is authenticating, who is logging in somewhere. There are also variations of this where services are talking to each other. So it's not me as the individual logging into a web page or authenticating directly to someone, but it's some kind of service. It's an agent. It's a hub. It's a personal data store, which is talking to another service, right? So this is not with a web browser, not with a mobile app, but just service to service interaction, basically running any kind of protocol, any kind of messaging, any kind of data exchange between two services could also be authenticated using DIDs. This part is very relevant to the typical sovereign architecture, right? In sovereign, there's a concept of agents, where there are always agents acting on behalf of individuals and organizations and also things. And these agents, they need to authenticate. They need to establish trusted, mutually authenticated channels, and that's also DID Auth. So that's also a form of DID Auth, and there have been different ideas on how that could work. So one idea is to reuse the traditional TLS protocol, also known as the SSL protocol. That's what makes the browser bar turn green when we're when we have an encrypted browser session. So it is possible to use the TLS protocol to establish an encrypted and authenticated channel between two services, and using the traditional TLS handshake, we can use not traditional certificates that are issued by hierarchical certificate authorities, but using certificates that we issue based on our DIDs. So we can use the same mechanism, the same certificate model, the same handshake protocol, but based on private key cryptographic material associated with a DID, and now suddenly we can have a trusted, encrypted, and authenticated channel between services. This particular approach of using TLS, so a lot of people, Sam Curran and others have looked at this, and this seems promising, except for the fact that there are a lot of implementations of TLS out there that make this really difficult. So this is still an topic or subject of ongoing research. This is very interesting theoretically. There are some challenges still with implementation. There's one other way of doing authenticated service to service interaction is to use a specification called HTTP signatures. So HTTP signatures is a way to authenticate messages not on the lower transport layer, but on the HTTP protocol layer. So it basically allows an HTTP client to send any kind of HTTP message to an HTTP server, and in that case, the server would be the DID Auth relying party, and the client would represent the identity owner. So you can basically sign an HTTP request with a DID, and the HTTP server, the relying party, will be able to validate that a certain HTTP request was really signed by a certain DID. Remember, there's always DID resolution, right? So we're always proving control of a certain DID. The relying party can validate that it's interacting with a identity owner identified by a certain DID, and it uses DID resolution to obtain the DID document and to validate the DID auth responses, the DID auth signatures. One more. This is the last one now of these complicated diagrams. I have to admit they take some explanation. This is the last one. This is also service to service authentication. This is what Sovereign is and Hyperledger Indy. Those projects are currently working on. So there's also a way to send authenticated messages between two services that are using something called auth encrypt or authenticated encryption. This is a special or a feature specific to the ED 25519 keys, and which are used by Sovereign, which are not used by other DID methods. But if a certain DID uses this specific type of key, ED 25519, then it's possible to encrypt messages and authenticate them at the same time. And the advantage here is that then basically you can send this over any transport mechanism. So you can encrypt and authenticate messages and then send them over HTTP or Bluetooth or NFC or attach them to an email or whatever. So this is also a really nice form of DID auth. It's also a form of DID auth where there's a message, there's an interaction signed by a DID, and that's can be validated by the relying party. So these were some example diagrams and some example scenarios how DID auth could work, and there are many other forms, many other architectures, how the different pieces and different components can be arranged and put together. I have some examples here now of the data format of these. We were talking about DID auth challenges and responses, what exactly that would look like. Again, there's not a specification or standard for this yet. There are only some ideas and some patterns that we are seeing that people are using. One pattern, one data format that's being used in DID auth implementations is JWT, JSON Web Token, which is also the format that, for example, OpenID Connect is using. So it's a mature, it's a well-established data form specifically made for authentication and other purposes. It has many implementations. It's quite successful. So a DID auth response sent by an identity owner to a relying party using this JSON Web Token format would basically look something like this. So there's it's a JSON document, and it has an entry called an issuer and a subject, right? And in traditional OpenID Connect, this would be different. If I do a login with Facebook, right, or login with Google to a website, and there will also be a JSON Web Token, but the issuer will be Facebook, or will be Google, and the subject will be the user. But here we can use the same format for DID auth, where I'm issuing that to myself, right? I'm issuing a token. What is my DID, and then I'm attaching a signature to prove that I actually control the private key corresponding to this DID. So this is one data format that could be used for that, which we're already seeing. Another kind of data format that we're seeing is based on JSON LD, which is the same format that W3C Verifiable Credentials working group is using for verifiable credentials, right? So a university issuing a diploma or a government issuing a driver's license, those are verifiable credentials, and you can use the same format and the same signature mechanisms for a DID auth protocol. So you could have verifiable claim or verifiable credential where you are the issuer and you are the subject, and you are claiming that you have a certain public key, and then you're proving with a cryptographic signature using something called linked data proofs or linked data signatures. You can prove that this claim is true, that you are actually issuing a claim that you control a certain public key associated with a certain DID, and this is something the relying party can validate. And got a third example here. This is for the HTTP signatures, HTTP signature variation that we talked about. So if you want to implement an HTTP client that sends an HTTP request to an HTTP server, and you want to authenticate that request with a DID, you can use the HTTP signature specification, which basically adds an HTTP header, and this is very, very confusing and not correctly named in some way because it's called authorization rather than authentication. But basically, with an HTTP request, you can include this header, and it says this is my DID, and here is a signature on the entire HTTP request, and then the relying party, the HTTP server, can validate that this request was indeed sent by a certain DID. At this point, I have a few slides on how DID Auth fits in with other things. So one question that comes up a lot is how does DID Auth relate to verifiable credentials, right? Both have to do with identity, both have to do with DIDs and with cryptography, and then there have been three different, in my view, there have been three different ways of thinking about how they relate. One approach I've seen is to say that they are separate things. That DID Auth is about proving control of a DID, right? It's a protocol or a mechanism where I prove that I control a certain DID. And then verifiable credential is something else. A verifiable credential is the university says that I have a diploma, or the state says that I have a valid driver's license. And this is an approach that you see, for example, in sovereign agents, right? In sovereign agents, the concept is that first you establish a connection. You establish a connection between agents, and in that connection, those agents are mutually authenticated, and then once you have this connection, then you initiate some other kind of protocol which allows you to do verifiable credential exchange. You can offer credentials, you can request credentials, you can offer proofs and so on, proving that you're over 18 after you've established what the DIDs are in the connection. So this is one way of thinking about it. Another way of thinking about it is that DID Auth and the exchange of verifiable credentials is somehow related. So, for example, the case where you log into a website. When you log into a website using one of these scenarios that we talked about, you can log into the website and simply prove that you control a certain DID, and that's it, and the website knows what your DID is. But you can also use the same protocol and extend that to, for example, prove what your name is, or that you have a certain education or a driver's license, that you're over 18. So there could be a single protocol which allows you to prove control of a DID. And the protocol could have some kind of extension that also allows you to include credentials, so that the relying party can learn not only your DID, but also learn more about it. This is something that we see, for example, in the UPort implementations and others. And to take that even a step further, it's also possible to think of DID Auth itself as a type of verifiable credential. So you could say that DID Auth is maybe the most trivial, the most basic verifiable credential that you can possibly imagine. And that takes us back to the very beginning. It's a credential that I issue about me, that I am me. Right? It sounds a bit stupid, but that's really one way of thinking about this, that proving that you control a certain DID and proving what your name is and proving that you're over 18 and so on is really not so different, right? So there's someone else making a claim that you're over 18, and then there's you making a claim that this is my DID, and it's really all part of the same protocol. So think about this a little bit. I'd be interested in what other people think about this. Okay, one slide about object capabilities. I'm not sure if it's worth going into detail too much about this. This is basically about authorization and permissioning. So we, in the DID Auth work, we basically decided to leave that out of scope. DID Auth is about proving control of a DID and maybe proving who you are, but then authorization and permissioning, and now what are you actually allowed to do? Not that you prove something about you. That's a separate concern. So we try to keep that separate. But if you're interested, there is very interesting work going on something called object capabilities. Capability is an interesting authorization model where you are allowed to perform certain actions or to do certain things based on a capability that has been issued to you, and not so much based on who you are. So it's an alternative to a classic access control list model. But that's not really in scope of DID Auth itself. So DID Auth plays a role in proving who you are and plays a role in obtaining verifiable credentials and so on. But it's not really about permissioning. So just because you perform a DID Auth interaction, that alone doesn't really, or in this model at least, that alone should not give you permissions there directly. One slide about biometrics. It's a very sensitive topic. So mostly DID Auth is about public key cryptography, and there's a challenge, and then there's a response which is signed with a key. But public key cryptography is not, strictly speaking, not the only way how control of a DID can be proven. So there could be authentication mechanisms, for example, involve biometrics, so where you prove that you control a certain DID, or where you prove who you are based on biometrics. So based on something that's inherently a part of you, right? Biometrics have advantages. Biometrics are available to everyone. Everyone has biometrics. They are unique to you. They don't require digital storage or electricity, right? They're always available, but also since there's also a sensitive topic because biometrics cannot be changed, right? They're always the same. But they can be used in a DID Auth interaction if it's done the right way. So mostly when we talk about DID Auth and biometrics, then most of the time biometrics are used only to unlock a private key on a certain device, right? So you could have a wallet, a mobile app with a wallet with your private key, and your fingerprint, for example, or your iris scan is needed in order to unlock your mobile app and in order to unlock the private key, and then you can cryptographically sign a challenge and return a response to the relying party. So there are no biometrics, fingerprint data, biometric input data actually exchanged between the identity owner and the relying party. So it's mostly about unlocking secret key or secret authentication material on the device. And there are some standards and some protocols that define how to actually actually do that. In theory, it is possible also to design DID Auth protocols where biometric data is exchanged between an identity owner and the relying party. So I could give I could outline quickly what that could look like. So in theory, you could have a biometric template stored inside a DID document, and then in a DID Auth interaction, exchange biometric input data, so a fingerprint scan with the relying party. The relying party could look up your DID document and then match your fingerprint, match your input data against the biometric template data that's in your DID document, and that would give you a way to perform DID Auth without cryptographic keys, without private keys, right? So you only have the biometric input data and the biometric template data, which is in your DID document, and then you could prove to a relying party that you control a certain DID by presenting certain biometrics that match the biometric template in the DID document. But that's more of it's mostly a theoretical approach because there are too many downsides if this is done. Biometric data, even biometric template data in a DID document has too many risks of correlation and surveillance and privacy problems and so on. But just in theory to share some thoughts of this. There's a separate paper also coming out of rebooting the Web of Trust community. It's called 6 Principles for Self-Sovereign Biometrics. So there's even a term, self-sovereign biometrics. It basically says there's no biometrics on the blockchain and no biometrics exchange with a central authority. We've done a little bit of work, a little bit of thinking on how to reuse protocols and standards that already exist. So a lot of people are asking, now there's this concept of DID Auth. What is it exactly? Couldn't it be built with OpenID Connect, and couldn't it be built with, or couldn't it be built, for example, with web authentication, which is also a web standard? And the answer is yes. So as we saw, DID Auth is still pretty much a high-level concept with different flows and different potential scenarios. And some of these scenarios could reuse aspects and parts from these established protocols. And we've had these discussions, and we've had sessions and some conceptual work on what that would look like. So, for example, you could absolutely implement an OpenID Connect interaction where where the identity owner has a personal OpenID Connect provider, right? So that's the main idea of DID Auth, right? You're not relying on an external identity provider, but you could run your own OpenID Connect service that acts on behalf of the identity owner, which could be discoverable again from the DID document. Then a relying party could initiate a standard OpenID Connect flow to authenticate a DID, to authenticate a self-sovereign identifier. Obviously, that would have the advantage of being able to reuse a lot of libraries and a lot of code that's already out there. And similar for web authentication. So web authentication is a standard where you log in. It's also a login, a single sign-on, or a login standard where you sign into a web page, and in standard web authentication, you prove control of a certain public key. This could be modified to instead prove control of a certain DID. Instead of proving control of a static public key, you prove control of a certain DID, but reusing the same similar mechanisms. And only 3 more slides, I think. Here's one. We've been thinking about using DID Auth or using DID-based authentication potentially in any scenario or in any technology that currently relies on static public keys. So wherever we have something that works with public key cryptography, where you traditionally work with static public keys, you could instead work with DIDs, because you can always resolve a DID to a public key. And with that, you could build better versions of PGP or SSH or other things. So, for example, I could send you an email, and I sign the email using something like PGP, but I modify that a little bit so that I don't prove that the email was signed by a certain public key, which in PGP you always exchange in advance. But instead of signing the email with a key that is static, I can sign with a DID, and the recipient could look up the DID and could verify that this email was actually sent by a certain DID. Or SSH, if you are a server administrator, then you know that there's on your server there's a file called authorized keys. That's where you can configure public keys for the people who are allowed to SSH into your server. So you could imagine a modification where instead an SSH server configures a list of DIDs, and anyone who has the corresponding private key to the DID could then log into the server using SSH. And then of course you can potentially combine all these things with verifiable credentials and cryptographic proofs. So you could even have maybe a version of an SSH server where you allow anyone to log into the server who has a valid driver's license, or who is an approved member of an organization, or things like that. So there are lots of other things too, lots of ideas where DIDs and DID Auth could be used instead of using traditional static public key infrastructure. A few security and privacy thoughts. First one being very important, the idea of directed identity. That's the concept that when I interact with different relying parties, I want to present myself to those different relying parties using different identifiers, using different DIDs, in order to avoid correlation. So when I log into one relying party and then I log into another relying party, I don't want them to know me with the same identifier. I don't want them to be able to link what they know about me. So this is known as pairwise pseudonymous DIDs. There's a lot of interesting work happening in Sovereign on this concept of micro ledgers, which basically allow me to set up DIDs, to generate DIDs that don't go in a public ledger. They are not registered on a public blockchain. They're only shared between an identity owner and the relying party. So there's a very peer-to-peer model, really, where a DID is essentially constructed dynamically. Whenever I interact with a new relying party, whenever I start a new DID Auth interaction with a new relying party, I create a new DID, and there's only peer-to-peer connection between me and the relying party. It's still DIDs. There's still the DID resolution. There's still a DID document, but it just doesn't live on a public ledger. Second point, going back a little bit to the terminology that came up earlier, there are cases where the identity owner, so the party who is identified by the DID, is not actually the same as the party that controls the DID. So there are cases like digital guardianship, for maybe where the DID identifies a child, but it's actually the parents who are performing the DID Auth or other kind of protocols. There are some thoughts about single logout, which is always an important or challenging feature in traditional authentication protocols. I want, after I've authenticated and logged in and established connections with a lot of relying parties, I usually want a way to revoke those, to log out everywhere, right? So all DIDs can be revoked. DIDs are a core, one of the core operations that every DID must support is revocation, termination of the DID. So if I do that, then DID Auth must also be able to end all the sessions, all the channels, all the relationships that I have. Another final slide, just going back to the very beginning, some thoughts on semantics. So there's a lot of discussion on semantics in verifiable credentials and proofs, and in the sovereign community also. How do I express really in a machine readable format a statement about an identity? So we've looked a little bit at the JWT and HTTP signatures examples, and we've looked at JSON LD verifiable credentials, where we're making a semantic claim, a semantic statement that I have a certain public key, so a statement that is machine readable based on semantic web technologies, where we are saying this is my identifier and this is my public key. But strictly speaking, from a semantic perspective, this is still not a statement that says I am me. This is only a statement that this is my public key. And without really going into any detail, or without looking at this syntax in great detail, there's also a data model and a protocol called XDI, Extensible Data Interchange, which is a semantic data model and a semantic protocol where it actually is possible to make these statements. So there's a way to express this is my DID. There's a way to express I am Markus, and there's even a way to express, strictly speaking, I am me. And this is what it would look like. There are features called local root nodes, relative identifiers. We could do a separate session on that at some point, maybe. But think a little bit about this. How do you say I'm over 18? I have a valid driver's license, and then how do you say that I am me? This very simple statement, which is the name of the cute little creature, and which is really the essence of DID Auth. That's it.
Nice. Markus, maybe if you want to go to the last slide, and I don't know if there are any questions coming up from anyone else. Not right now. I just want to check with you two things, because at the beginning you mentioned that there's no specification or no standard right now around DID Auth. How does the roadmap look like? What are the plans?
So there's now this paper coming out of the Rebooting a Web of Trust community, which is basically collected community wisdom, or a survey of an overview of all these different aspects of DID Auth. We have talked about starting to work on specifications, and we'll probably start with some of these, one or two of these examples, right? So we may start to work on how do you do HTTP signatures with DIDs, or we may work on how do you log in using a QR code to a web page. So we'll start with some of these, but they will be done at W3C and the Credentials Community Group. We're also working. Probably we will first work on DID resolution, so that will be a separate specification for DID resolution, and then after that we'll start working on specifications for DID Auth, which may be modular, right? There may be 2 or 3 or 4 or a number of different specifications that address different flavors of DID Auth.
Okay, great. I have 2 questions coming up here from Nick. Nick is asking, what is that Danube Tech developing in the space?
So Danube Tech is my small consulting and development company here in Vienna. Danube Tech is really involved in a lot of efforts in this space, contributing to Sovereign, contributing to Hyperledger Indy, contributing also to the Decentralized Identity Foundation, DIF. And in DIF, there are a few repositories that implement some of this DID Auth. So there's an example browser plugin that allows you to log into a website with a DID, and there's also an example implementation of HTTP signatures with DID. So Danube Tech is just contributing to a lot of components and a lot of pieces, including also a DID resolver. So maybe it's worth doing a separate webinar on that at some point. But that the basic component that translates a DID to a DID document, that's DID resolution. That's the prerequisite really for DID Auth or any other DID-based protocol, and we're also heavily working on that.
Great. And Nick has a follow-up question on this one too. I mean, he's asking are DIF and Sovereign aligned on DID Auth?
They are aligned on DID Auth on the high level insofar as on the understanding that DID Auth is about proving control of a DID. Like we saw, there are many different flows and scenarios, and we'll see. And Sovereign, for example, is focusing on agent to agent, service to service authentication. But DIF is doing something very similar. It's working on hubs, identity hubs, which also need to authenticate to each other, and a lot of this is still evolving. A lot of this is changing, so I can't give you a definitive answer on whether they are implementing the same thing. But there's constant exchange, and there is really an effort to interoperability.
Okay, great. If once these things get, I mean, like implemented and we get specifications or like standard use cases, I mean, like in reality, I mean, if I understand it correctly, it's like really with DID Auth, like the most basic use case, but which is really very important, like authenticating yourself for accessing the website. That could then really start for a number of services, right? Is that correct?
Yes, it's like I said in the beginning, I think it's really the most straightforward, most immediate, most logical thing that you can possibly do with a DID, just to prove that you control it, to log in to a web page, and it's going to be an actual protocol. There will be specifications and implementations. So fulfilling similar purpose and maybe at some point achieving similar ubiquity at things like login with Facebook, login with Google, very much like that, but self-sovereign.
And how far away do you think that is in the future? Like, what do you think is realistic?
Well, early implementations exist now that can be tested and looked at in DIF or in Sovereign or in UPort. There are a lot of things that you could call DID Auth right now. Getting to a point where it's standardized and everyone will agree and it will become actually available to everyone, that's going to take a while. So maybe next year, not this year. So. It depends on DIDs, depends on DID resolution. There will be specifications, there will be drafts, then there will be implementers drafts, then there will be interoperable implementations, then there will be new implementers drafts, and there will be updated implementations. There will be test cases, there will be interoperability testing, and then at some point there will be a standard, but it's going to take a while.
Okay, great. I mean, it seems there are no other questions. If there are no other questions, I think this is great. I received a lot of messages of people that had to leave, but they said this was a great session. So thank you very much, Markus, for taking the time. I'll make the recording available as soon as it's ready, machine, and send it out. Please join the Telegram channel we have, where we announce all the webinars we're doing. Or the Twitter or the newsletter channel, whatever your favorite method is for receiving information. And yeah, join those channels. We will be doing more sessions with Markus, hopefully, if he has time, and the number of ideas we have to discuss. And we will try to find slots with Markus and to get his valuable insight. And thank you everyone for joining us today, and thank you especially to you, Markus, for sharing your knowledge with us.
Thank you very much. That was great.
Okay, thank you. Bye.